let's try this. Okay. All right, so again, we're in 7.3. If you're wondering, 7.3. Now we're talking, we did reflections yesterday. We're doing rotations today. So graph the results of the rotations on a coordinate grid. So all I did was I stole this image, and instead of simply doing a 180-degree turn, I'd like to do a 90, a 180, and then a 270. Okay, so what I want to produce, eventually I want to produce that. What am I starting with? I'm starting with that. So it's not a very hard process. I feel like it's a slope of the line type thing, which you learn later. But again, if you're doing a 90-degree turn, I know you're not talking in that back corner and probably not understanding the math. So basically you want to do 90-degree turn to start. So the easiest thing we're going to do is it's going to say a reflection about the origin, Daniela. A reflection about the origin, meaning everything is in relation to the origin. So all I do is I'm going to use dotted lines here to get me back to the origin. Okay? And now I want to do, let's try this as a 90-degree clockwise turn. So all I do is you have to take out your trusty protractor. You got to put the crosshairs on the origin. Follow your line, and you're going to end up with a 90-degree point right around there. Now you connect the dots, and you end up with A being right there. Now, first of all, how did I know? That's where my A is going to go for a 90-degree reflection, or sorry, 90-degree rotation, clockwise. How did I know? Okay, sure, it's easy enough to measure back to the origin and then put a 90-degree line on it and go out this way. Sure. How did I know not to put the point over here, over here, over here, or somewhere else where this dotted line would have continued? How did I know to put the point there? Now, the example that it's going to give you in the book is fairly easy because they're typically all going to end up where the x and the y axis meet up at a certain particular coordinate, not decimals or anything like that. But here you can count down to the y axis, and then if I wanted to make a 90-degree clockwise turn, we just did that on the other sheet of paper, you go down and then to the right. So if it's 3 down, it's going to then be 3 right on your line that is a 90-degree turn. Or you can count down 3 and back 1 is going to equal across 3 and down 1. I think the easiest way to do that, if you want to measure it, you can do that. But I think the easiest way to do it is to understand that for a 90-degree turn clockwise, you have to go down and then to the right. So if you go down on the y-axis, 3, you have to go right on the x-axis, 3, and put your point along the 90-degree line. So we'll try another one here. Again, if I'm trying B, it gets a little mixed up with A just because the lines back to the origin are somewhat close together. If there's my line for B, that's, you probably can't see unless I zoom in. So you can see a faint dotted line going all the way from B to the origin. You put your protractor on that line with the crosshairs of the protractor sitting in the origin, and I'm going to end up with 90-degree point being right there. I draw a 90-degree, or sorry, I draw a dotted line from the origin through my 90-degree point, and I end up with a line going off in that direction that way. Now, if I go to B, I have to turn 90 degrees to the right. I have to go down to the x-axis, and then I have to turn right or left. I have to turn right. So I'm going to count down. How many do I count down? I'm at 7, so I know I count down 7. So that means I have to count right 7. To count down 7, that means I count right 7. And I put my points somewhere along the line that is down 7 and across 7. That's on the line, and it's 1, 2, 3, 4, 5, 6, 7. It's on my line that is 90 degrees compared to the line from B to the origin. This is then B reflected 90 degrees. Reflected, sorry, thank you, rotated 90 degrees. Okay, so let's finish this up here really quick. Again, your step every single time is to go back to the origin with a dotted line, throw your protractor on that line with the crosshairs at the origin, and you're gonna end up with a point at 90 degrees, which will be right there. You then take your ruler, put it at the origin and the point, and you're gonna draw your dotted line all over again. And you know that your point for C is at 6 and 6. So to get a 90 degree turn to the right, you have to go down 6 and then right 6. So 1, 2, 3, 4, 5, 6 to get down to the x-axis. So then I'll now start at the y-axis and I'll go 1, 2, 3, 4, 5, 6. So it's got to be at 6 and it's got to be on my 90 degree line. So where the two lines meet, I end up with on 6 and on the line, I end up at C rotated, 90 degrees to the right. Yeah? Okay, I hope you guys are finding this easy. If you're not, I see a couple of puzzled faces around the room, but we'll keep going here. So we get D. Again, my line is to draw a dotted line back to the origin, and then gonna put my protractor on that line, and with the crosshairs of the protractor at the origin, 90 degrees would be there. And I then connect a dotted line to the origin and the dot that I just put at 90 degrees. And I end up, if I look here, I have to count back to the y-axis. I have 1 here to get back to the x-axis, so I go down and then to the right. So I have 1 to get down, so then I start at the y-axis and I have 1 to go across. Because it's 1 here, it's got to be 1 here. I find a point along 1 that is at that line, and that's going to be my D rotated. I connect all those dots, and that's going to equal, A, B, C, D, rotated 90 degrees clockwise. Okay, who thinks easy and hard? Should have done it last year, yes? Okay, do you know a shortcut to figure that out by any chance? No? Okay, so what I'll do is I'll show you this. And so what I did here was I just produced, if you look here, we have this, which should look the exact same as this, except for this half, which I did on my own because I'm kind of sad and all the rest. So all this is going to equal will be your original image rotated 90 degrees to the right, and then your original image rotated 180 degrees, and then your original image rotated 90 degrees counterclockwise or 270 degrees clockwise. Right? I recommend always doing the 90 degree turn if it gives you a 270 degree turn clockwise to make that a 90 degree turn counterclockwise. If it gives you a 270 degree turn counterclockwise, I would just make that a 90 degree turn clockwise. So I did it all for you here, or I did it all on my own here. Again, your steps for this we did just now. You go down to the x-axis, so then you go right to the x-axis. for a 180-degree turn, you just take this image and at whatever you went down to the origin here, you continue that line. Just continue it on your ruler. You go down 3, you go down 3, and on your straight line, that's where you will find your points. We can go through a couple of examples of that. And then this is the exact same process as this, except instead of putting your 90-degree line going that way, you put your 90-degree line going that way. Now let's try coordinates. So all I want you to see is how easy it is to do without actually drawing it all out. Now this shortcut can be found in your book as well. I'm going to need your help telling me these coordinates. So if I look for my coordinates here, I can see that D is 3 and 1, C is 6 and 6, 3 and 7 for B, and 1 and 3 for A. Now, trick time. So your coordinates here for A are going to be 3, -1, B is going to be 7, -3, C is going to be -6, 6, and D is going to be -1, 3. Now, does anyone think I'm ridiculously smart and can look at that in 2 seconds and figure out what the coordinates are? No. I'm not. So how did I do that? There's a trick to it. Can anyone see the pattern? Take a look at A and see what the pattern is. Take a look at B and see what the pattern is. Again, you're remembering that your coordinates here are always X, Y. The numbers are very similar, are they not? B is very similar to B. C is very similar to C. D is very similar to D. What do you do? Yeah. C is wrong.
D is 1 and
Oh, right. Okay, sorry. Seven -3, 6 -6, and D is 1 -3. Sorry, thanks guys. Okay, so you're obviously trying to figure out your pattern. Perfect. What is it? XY, Baxter, XY simply becomes Y, 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 -X, or Y opposite X. Does that make sense? Now, you can figure it out all you want, and you can go through and draw your, I'm telling you, the actual process, if I tell you to show your work, Alejandro, the actual process, I want you to draw the dotted line, put the protractor on it, draw the dotted line back, find the dot along the line by counting down to the axis and across from the axis, or whatever the turn is going to be, down and right, down and left, whatever it is. But to just simply figure out the numbers, X, Y just becomes Y and the opposite of X. So I'm not going to tell you what well, I will, I guess. You can do the exact same thing for XY here. If you do a 180-degree rotation, all it becomes are the opposite of both. So if your coordinate is 1, 1, and you rotate it 180 degrees, you have -1, -1. The same idea for XY here, getting rotated 90 degrees counterclockwise. All you have is, instead of XY becoming Y negative X, you have XY becoming -YX. Now I'm going to tell you to figure it out for one, and then you'll understand the pattern and we'll go from there. So we'll try this now.